Before we show you our device, let us explain why we chose UVC LEDs. UV or ultraviolet light has three main types: UVA, UVB, and UVC. However, UVC light can eliminate viruses and is currently used on airplanes and in hospitals to disinfect surfaces. UVC has also been proven to work on SARS-CoV-2, the virus that causes COVID-19. This is why we chose UVC LEDs for our disinfection device.
For the hardware, we used one Arduino Uno microcontroller, 16 LEDs configured in a 4x4 array, one through-hole board for soldering our LEDs, 4 X9C104 digital potentiometers to adjust the intensity of the LEDs, one ultrasonic sensor for detecting the distance between the LEDs and the surface. We used 4 A011 Lux Drive constant current LED drivers for powering LEDs at 700 milliamps. We used 4 12-volt A23 batteries to power those drivers, one 9-volt battery to supply power to the Arduino Uno, 2 KCD3 rocker switches, one for turning on the 4 drivers and the other for turning on our microcontroller. We used one HC05 wireless Bluetooth module to connect to our phone application, one solderless breadboard, a 3D printed case to house our electronics, and finally jumper cables for wiring all our components together. There were a few important design considerations our team needed to make for the hardware development of our disinfection device. If we would have placed all our LEDs in series, we could have potentially risked the entire system failing, so operating in partial series in parallel was a suitable option for this project. This is the primary reason why we chose to build and configure a 4x4 array of LEDs. This would make certain that if one LED went out, only one row would be affected and not the whole entire system. Therefore, the device would still operate as intended, even if compromised by one LED burning out. It was essential in our design to use 4 LED drivers to power all 4 rows in parallel. The purpose of the LED drivers is to keep the current constant throughout the system at 700 milliamps to provide stability and efficiency for driving our LEDs.
To drive the device, we needed to build an Android app that could control the UVC LEDs. To do this, we chose React Native to build the app, Expo to test and deploy it, the Google Play Store to host the app, and an Arduino to control the LEDs. The application we designed can start and stop a cleaning cycle and displays information to the user, such as how much time is left on a cycle, how far the device is from the surface, and if the cycle was canceled for any reason. Since we are working with UVC light, we implemented safety measures to ensure the light only shines on the intended surface. If the device moves too close, too far from the surface, or it points in a different direction entirely, we cancel the cycle and notify the user of the problem. We chose React Native to build the app because it's a great framework for building smartphone applications and can be deployed on either iOS or Android. We then uploaded the app to the Google Play Store to be downloaded on Android devices. This is the case we used to house our device. On top, there is a cutout to be used as a handle. The case has multiple layers to hold all the electronics. And on the bottom layer, there are 2 cutouts. One for the PCB that contains the LED array, and the other for the proximity sensor. The individual parts stack on top of each other to create a shelf system that makes maintenance easy. Additionally, there are gaps on each side of the shelf to allow wires to pass between layers of the device. Finally, to keep everything together, we use screws to fasten the lid to the rest of the device. We 3D printed each part of the design using blue PLA plastic for the base and white ABS plastic for the lid. The final design is light, sturdy, and easy to hold.
Here is our microcontroller Arduino code. These are just some initial variables that we use. our initial setup, our loop, which contains our run cycle as well, which also calculates the varying bar that you see on our screen. It also controls our distance calculation, our boundary calculation, which shows the user how much space they have before the device will shut off, and the percentage bar as well, and the runtime as well. Our distance check is just to make sure that the device is still within range. Now we'll compile the code to verify that it works. And we will upload the code to our Arduino for use in the device. Okay, here we're going to connect my Android smartphone to our device. It's looking for it right now. It's getting the device name, and in just a moment it will show the HC05. Alright, I'm going to tap on it to connect to it, to pair it with the device, and we just have to test a couple pins to make sure it works. So 000 didn't work, so we're going to pair it with 1 2 3 4. Alright, now that it's paired, we're going to go back to the app. We have to reopen it to refresh the Bluetooth connection. And as you can see, it's at the bottom of the screen, HC05. I will connect to it. And once I tap the Start Stop button, the cycle begins to run.